Okay, grade 4. As we started talking about today in our math lesson that was not ideal, it was not the best math lesson in the world, and I apologize for that. I think that it might have been a little bit confusing for some of you. In order to understand area, it helps if you really understand multiplication. And that's what we're looking at now, actually, is we're looking at multiplication, but through area. So we know that area is always calculated. I'm going to write down here, area is length times width. That's the formula for finding area. It always works. So yes, we know that the area of Forrest's room is going to be, the area is going to be 20 units times 20 units. And we know that the area of Miss Field's room is going to be 25 units times 15 units. But I don't want us to just rely on algorithms and formula, because when we do that, it can mask the fact that we maybe don't understand things as well as we want to. So I want to come back up here to Forrest's room and talk about Powell's strategy that we shared this morning in the lesson. What Powell was doing that was so powerful as a mathematician, and she was looking at this 20 times 20, and she was finding some smaller equations hiding inside. She could see that 20 times 20 is the same as 10 times 10 plus 10 times 10 plus 10 times 10 plus 10 times 10. So she broke up the 20 into 10 and 10, and she broke up the other 20. Whoops. She broke the other 20 into 10 and 10 as well. So now she's looking at smaller equations inside this bigger equation. This shows really, really powerful mathematical thinking. Okay, I'm trying to color this in, but my coloring isn't very good. I want you to just pay attention less to my coloring and pay attention more to the math, okay? So what Powell was doing is she could see that there were some smaller equations hiding inside this big equation. And the way that she did that is she broke the 20 into numbers that were easier to work with. That's really all that mathematics is about. It's about breaking bigger numbers into smaller numbers to make them easier to work with. And with questions like 20 by 20 or 20 times 20, that seems less important because some of us know already this rule. And we're going to talk about this rule a little bit later in more detail. But some of us know this rule that 20 times 20, we can just look at 2 times 2 to start, and 2 times 2 is 4, and then we add. This is the language that I'm trying to get you away from using. We can add the 2 zeros. That's a trick, a short form. We're going to talk a little bit more about what that means later, but certainly we can do that. That's an easy calculation to make. But unfortunately, that same ease of calculation doesn't work when we look at Miss Field's room. Miss Field's room is giving us an equation of 25 times 15, 25 units times 15 units, and 25 units times 15 units is much harder to calculate. This is a place where it's much easier for us to find a smaller equation hiding inside a bigger equation. Now I've got here 15 rows, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 1, 2, 3, 4, 5. Each of these rows has 25 square units in it. So I might want to break this up to make it easier to work with. One way I could do this, and I think Sagi did this in his work this week, is he took this 15 and he broke it up into 10 and 5. I would call 10 always a landmark number. It's an easier number to work with. So now we've got a 10 times 25, and we have a 5 times 25. And if you know that 5 times 25 is 125, then this might be enough for you. But most of us don't know our 25 times table, and we don't know our 5 times table up to 25. So we might need to break this 10 times 15 up into even smaller bits to make it easier to work with. So one thing that we might want to do is to break up this 25 into 20 and 5. And if we do that, we don't have 10 times 25 anymore. We have 10 times 20. And we don't have 5 times 25 anymore. We have 5 times 20. And then we have here 10 rows of 5. And here we have 5 rows of 5. Now we have 4 smaller equations that are easier to work with. 10 times 20 equals 200. And because we're dealing with area, I'm going to put units squared there. 5 times 20 is 100 units squared. 10 units, I could put the units in there to make it easier to see. Okay, 10 units times 5 units equals 50 units squared. And 5 units times 5 units equals 25 units squared. Now, when I add all of those little bits up, I'm going to get 200 plus 100 plus 50 plus 25. I know that 200 plus 100 is 300. 50 plus 25 is 75. It gives me a total of 375 units squared. So these are 2 ways that you could break up that bigger equation into smaller parts to make them easier to work with. These aren't the only ways. You could look at other ways as well. I would like you to go back to your math work and see if you can't find a way to break up your bigger equations into smaller equations to make them easier to work with.